Hey everyone, welcome to homework 1.26. This one should be a pretty quick one. We are looking at more inequalities and just practicing graphing these systems of inequalities. So this first one says the organizers of a conference need to prepare at least 200 notepads for the event and have a budget of $160 for the notepads. A store sells notepads in packages of 24 and packages of 6. So those are the two types of packages. I'm going to go ahead and label packages of 24 as X and packages of 6 as Y, which we see right here. The system of inequalities represents these constraints. So explain what the second inequality in the system tells us about the situation. So it's asking, what does this inequality tells us? So this tells us we can't spend more than $160, right? That combined, the two types of notebooks have to be less than 160. It also tells us that the price for one package is 16 and the price for the other package is 540, right? So you could say that. So 16 for the large package and then 540 for the small package. All right, here are incomplete graphs of the inequalities in the system showing only the boundary lines of the solution regions. Which graph represents the boundary line of the second inequality? So it's saying which boundary line represents this inequality here. Okay, well, let's go ahead and put this in slope-intercept form so we can figure that out. So if we do that, we're going to subtract 16x from both sides. So we'll get 540y is less than or equal to negative 16x plus 160. And then we need to divide both sides by 540. So if we do that, and I didn't have my calculator up and ready to go, sorry about that, but 160 divided by 540, it's going to give us 29.62. So our y-intercept would be 29 point something. So that shows me that this line right here is our second equation. So I'm going to go ahead and label that 16x plus 540y is less than or equal to 160. Then it says, complete the graphs to show the solution set. So for that equation, it is less than or equal to, and so if I plug in 0, 0, that will work. It'll be less than or equal to 160, so I'm going to shade underneath the line for that equation. For the first equation, it is greater than or equal to 200. So if it's greater than or equal to, if I were to plug 0, 0, that would not be big enough. And so for the other graph, I'm going to be shading above the line. And so notice the area in which both are shaded is very small. It's that teensy-tiny little sliver down at the bottom there. So we've completed the graph. You can just draw a little arrow. Show me your graph. Find the possible combination of large and small packages of notepads the organizer could order. So there's a lot of different responses that we could have here, right? One could be 10, 0, because these are greater than or equal to, so on the line right here at 10, 0 would work. Another one might be 9, 2, right? That would be here and then about here. So 9, 2 looks like one that will work. But anything in this zone right here, this tiny little sliver of triangle, would work. All right, let's take a look at number 6. A certain stylist charges $15 for a haircut and $30 for coloring. A haircut takes on average 30 minutes while coloring takes 2 hours. The stylist works up to 8 hours a day and she needs to make a minimum of $150 a day to pay for her expenses. Create a system of inequalities that shows the constraints in this situation. All right, so the first inequality that I can make is about the time. And so that is going to be 1/2 hour, right? And so that's 30 minutes, right? 30 minutes is 1/2. So you can write that as 0.5 or you can write it as 1/2. Either one is fine. Say x for haircut plus coloring is going to be 2y. And that has to be less than or equal to 8 because we're talking about this in hours. And then in terms of cost, it's $15 per haircut plus $30 for coloring. And she wants to make a minimum, so at least $150 a day. So those are our two inequalities. It says graph the inequalities and show the solution set. So we're going to go ahead and solve for y, put these in slope-intercept form. we'll have 2y is less than or equal to negative 0.5x plus 8. Divide by 2 on both sides, we'll get y is less than or equal to negative 0.5 divided by 2 is 1/2 divided by 2, which is 1/2 times 1/2, so that will be 0.25. And then x, so that's the same as 1/4. And then 8 divided by 2 is 4. Okay, so that's one of our equations. I'm not going to graph it yet because I want to see what the other one's going to look like. So let's say we have 30y is greater than or equal to negative 15x plus 150. Divide both sides by 30. Get y is greater than or equal to negative 1/2 x plus 150 divided by 30 is 5. All right, and so now I'm looking at a graph where the y-intercepts are 4 and 5 and the slopes are negative, so that'll help me to graph this. Let's say 1, 2, 3, 4. We'll do increments as such. 5, 6, 7. Okay, we don't need to go higher than that. So 0.4 at 4 for our one equation, and down 1 over 4 because I have a slope of 0.25, which is the same as 1 over 4. So let me grade 1, 2, 3, 4, 5, 6. All right, so we're going to go down 1 over 1, down 1 over 1. Oh, sorry, down 1 over 4. Look at me. Okay. Down 1 over 4. Down 1 over, this would be 7, 8, 6, 7. Okay, so down 1 over 4. Okay, and so that gives you your one line right there. Okay, and so then, and it is, this first one is less than or equal to, and so less than or equal to means that we're going to be shading underneath this line, because if I test a point 1, 1, for example, that'll be less than or equal to 8. That works. The next one, though, we're looking at a starting point of, let's change the color to 5, and we're going down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, okay? And so this will be your other line, also a solid line because they're both or equal to. And then it's greater than or equal to, so putting 0, 0 in there is going to be less than. That's not going to work. So we're going to go to the other side of the line and shade this side of the line. Now notice again, that tiny little sliver is what actually fits both of these constraints. So this little sliver right there is what we're looking at. It says identify a point on that represents a combination of haircuts and coloring jobs that meets the requirements. So if we look here, for example, looking at possibly like 9-2 would work. Remembering that X is haircut and Y is hair coloring. So making sure to label those axes as well. So you can come up with some other ones. That's the one that I think is the easiest to kind of see there. So identify a point that is a solution to the system of inequalities, but is not possible or not likely in this situation. Explain why this solution is impossible or unlikely. So an example of this would be like, you know, maybe something with a decimal, because we wouldn't do, you know, something outrageously odd in terms of the number of haircuts or that we're cutting. Like we can't do half a haircut or half of a hair coloring. You have to do a whole one. And then another one you could say is maybe if we were to expand this graph out further, something where like the stylist is working for 16 hours straight, or doing 16 haircuts in a row, that seems like that might be unrealistic. So 16,0 would be a potentially unrealistic one. 5, or that's not actually a solution there. We look at like 9.5, comma 2.12, right? We're not going to do 2.12 hair colorings. All right, number 7 is matching. Match, find which equation matches, which graph matches this inequality. And so for this, I would strongly recommend you put the second one into slope-intercept form. So you're going to add 4x to both sides and then divide by 3. And so you want to look for an equation that, or an inequality on the graph that matches that. And then you also need to make sure you're shading. So I would recommend, honestly, that you draw this out yourself and shade, and then look and see which one matches the best. The other way that you can do that is that you can test a point that's in the shaded region, for example here, and test it in both equations and see which one works. But for this one, I want you to go ahead and work that out yourself, because you can definitely find the correct graph. So pick which graph matches. Again, you can test a point. That's one way to do it. You can put it in slope-intercept form and graph it and see what you get and what would work for you. But those are 2 ways to solve it. And then number 8 is matching each inequality to the graph of its solution. Again, to do this, I would strongly recommend that you put these into slope-intercept form first and then match them. But this is a simple matching activity, so I'm going to ask that you do this on your own, put it into slope-intercept form, and then match it with the correct graph. All right, that's it for today. Your code word is going to be, let's make it museum, since we went to the museum today. Okay, happy homeworking. See you tomorrow.